On today's episode, the most important concept in quality and metrology: accuracy versus precision.
Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today.
Accuracy, precision. Now, the people that don't work in manufacturing engineering or quality assurance, for those people, these two words are synonyms. For decades, advertising has touted everything from Swiss watches and German cars to Japanese audio equipment as precision engineered. But for professionals whose job it is to see that important attributes of mass production goods stay inside their customers' acceptable quality limit, accuracy and precision are not the same thing. Let me illustrate what I mean with a simple example using darts and a dartboard. The attribute we're measuring here is a dart on target on the bullseye. I'll throw all 16 darts, then let's take a look. What we're looking at here is an example of poor accuracy and poor precision. The darts are all over the board. Now let's try again. Now we have accuracy, but poor precision. If you use a coordinate measuring system with the bullseye at the origin, the mean of all the deviations of distance from the bullseye would be 0, but the individual measurements are still all over the place. So let's try again. Now we have very high precision, but very poor accuracy. The darts are consistently hitting the same spot on the board, but they're not on target. Now, this is actually better than it looks, regardless of whether it's the diameter of a hole, or the fit-up of a robotic assembly process, or the amount of sugar on a donut. A condition that is accurate but not precise suggests that the equipment is not capable in the quality sense of that word, or that it is operating at or outside its design limits. Now, I've seen this frequently with robotics and machine tools which are run at 100% feeds and speeds, and it's one reason why many manufacturing engineers operate equipment well within the maximum performance limits of production equipment, despite the loss in potential productivity. Accuracy without precision can be a challenging problem to correct, and an expensive one if the capability study shows that the piece of production equipment simply can't deliver both. Now, in the hole drilling example, the engineer would look for a wear in a bushing or a bearing, or maybe a concentricity issue or flex in a cutting head. High precision with poor accuracy is actually a much simpler problem to solve. A robot or a cutting head or a nozzle that can consistently deliver the same outcome, but one that is off target, can usually be adjusted to make it both accurate and precise, which of course is the goal. High precision with poor accuracy usually means a capable machine that is out of adjustment or has another problem such as fixturing. Of course, everyone wants both accuracy and precision, like this Boeing robotic assembly system for 777 production. But if you're troubleshooting a production problem and have to choose one, I suggest look for precision first and accuracy later. And for engineers who have to write reports, and who doesn't, a really good idea may be to stop using the word precision at all, mainly because it's entirely possible that the supervisor reading the report doesn't fully understand the difference between the two, and confusion can result. I suggest using the word repeatability instead of precision in those reports. Accuracy is good, but precision, or better, repeatability, really is what we're all after.
Well, that's it for today's episode of End of the Line, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.